So my name is Kostas, and my day job is senior researcher in computing and game designer at the Institute of Computing and Communication Systems in Athens. And I'm also involved in a number of outreach activities that have to do with technology and coding, one of which is the Europe Code Week, which took place last month. I'm going to talk about the Code Week a little bit later on, but you can see many pictures. Actually, all the pictures that I used in the presentation come from events that took place within the Code Week, so you get a rough idea of what happened. So many people think that coding is mostly an introduction to algorithmic thinking or to problem solving, however you want to call it. And this is partly true because most of the courses that take place in schools start from scratch, which is an open and free software developed by MIT and actually branched into different technologies and platforms and so on. And then they go on to Lego platforms, small robots that you can see outside in the foyer. And they try to take apart larger problems into smaller ones for students to solve them. But think about this for a minute. Most of the kids in schools, actually most of the boys in schools, define themselves as being closer to technology, to applied subjects, and so on. So if we stick with the traditional way of teaching, which usually involves pen and paper and teaching with blackboards and whiteboards and so on, it becomes increasingly difficult to motivate them and keep them closer to our curriculum. And this is also the case with some of the girls who try to escape from the traditional cliche that says that most girls are mostly interested in theoretical subjects. And in both of these cases, coding can come to the rescue. So it can be very useful to, as I said, retain boys within, retain actually their interest to the school curriculum, and also provide some sort of empowerment for girls who want to escape from the traditional cliche. You may have seen a video that went viral a couple of months ago. It showed a little girl that played around in the schoolyard, and the girl's parents instructed her to move away from the mud because she would mess up her neat clothes and so on. And in the next shot, the girl has gone to school, to primary school, and she's in the physics lab, and she tries to put together an assembly, but one of her male schoolmates offers to do the assembly for her because, you know, it requires muscles and power and so on. And in the final shot of the video, the girl stands in front of the poster that advertises a science fair, and eventually she turns away and puts on her lipstick because she was finally convinced to comply with the cliche that I mentioned earlier and stay away from STEM subjects. So there's a lot of things that we can do, and actually a lot of way to go in this framework, but there are lots of tools that you can use. For example, there's a very nice book about web technology called Ruby. It's called Ruby for Girls that you can download. It actually was the result of a Kickstarter campaign. And you can use it with primary school, with secondary school students, even with female adults, to try to empower them, to help them create their own digital stuff. Another issue related to coding is that in most cases, coding is taught within the framework of computer science. So it's a separate subject, a separate course, and in some cases taught by different teachers than the ones that teach the other subjects. But we should not forget that you can use coding to actually spice up the other disciplines. For example, you can put together, you can design and develop a pendulum simulation, and you can have your students play around with the different structural properties and the different physical properties of the simulations. And in this way, take the whole simulation and the whole physics class to the next level. Now, I realize that in some schools there are huge problems with the existing computer labs, especially with schools in isolated areas, and especially if you take into account that connectivity and good quality internet access is absolutely important these days. Actually, I would argue that connectivity is even more important than raw computing power, because at the end of the day, most of the software that you will run in your courses and most of the activities that will take place don't require so much brute force in terms of computing, but they do require some sort of interactivity or information exchange. But even if your computers in your labs are archaic, or even if you don't have computers at all, you can actually put together what is called unplugged activities. For instance, you can experiment with tangible objects, such as plastic coffee cups, and you can sort of program them by using instructions or directions written on paper, and have your students build together something complex, a complex structure such as a small tower, using the same concepts that they would use in conventional programming. Or you can simulate the way that messages are spread within the internet. For example, simulate the protocols that email uses or web access uses. And this way, actually educate your students about how the web is designed, what happens if a server breaks down, what is a server, what is a client, how network attacks perform, and so on. And maybe instead of just sticking with technology, you can also educate them about our highly connected work, about privacy, about security, or actually the lack thereof. Now, where to go next? I briefly mentioned the Code Week. It took place last month between the 11th and 17th of October, but you can actually add your events. I know that the Hour of Code is just around the corner, so you can add your events to the Code Week website and become a member of the largest teaching and code community in Greece. You can also find lots of resources translated to your language, and this is extremely important, of course, for Europe if you go to the website. Another obvious choice is the Hour of Code website. The nice thing about that website is that it offers a vast number of possibilities, ranging for very simple problem-solving exercises using Angry Birds and Plants vs. Zombies and other popular gaming paradigms, all the way up to drawing elaborate shapes or even programming your own computer game. In that website, there is also a number of videos featuring celebrities such as Shakira or Chris Bosh, the NBA player, which you can use to motivate your students or even the parents of those students to take up coding. And finally, another important aspect is that we desperately need to motivate young girls and females, adult females, to take up coding. And this is very important not only from the point of view of society, but also because we currently have hundreds of thousands of unfilled job positions that need to be filled, and this is actually holding the European economy and the European society back. And the only way to fill up those positions is if we have more and more and more women taking up coding, despite the possible lack of any formal education. So you don't really need to have a university degree in coding to become a programmer or to code your own stuff. Just follow one of the many activities that take place across Europe. In Greece, we launched the Girls Go Coding initiative last month in Athens, and we are very happy to report that it was very warmly accepted. So we still expect many things to happen to this end. These are the websites, the addresses of the websites that I mentioned. Now, think of the possibilities that you have when someone takes up coding. We cannot fly. We don't have X-ray vision. Last time I checked, we cannot climb on roofs or have any other superpower. But we can instruct machines to follow our instructions, starting from domestic appliances such as, I don't know, a Roomba vacuum cleaner, to mobile phones, to 100-kilo robots landing on comets in distant space. And that's the closest thing that we have to a superpower, and if you ask me, it's a pretty neat one. Thank you.